factors and greatest common factor. Alright, for vocabulary we have prime factorization, which is the process of breaking up a number into all of its different factors and keep breaking it up until you're left with only prime factors. Alright, and we're going to go through how to do that. And then we have greatest common factor, which is when you're looking at the factors of two numbers, it's the largest shared factor. Okay, doesn't have to be prime. In fact, it usually won't. Sometimes it will, but it's the largest shared factor. All right. So concept one is writing prime factorization, and generally we use what's called a factor tree to do this. Okay, we start with our number, and what we're going to do is we're just going to break that into two. Okay, and break that into two pieces, and you can use any two factors. I usually start with the smallest number. It's easy to tell if something has 2 as a factor because it's even, so that's what I'll start with. We've got a 2, and then half of 42 is 21. Okay, and 2 is a prime, so I'm going to circle that. 21 is not even, so I know 2 is not going to be a factor, but I do know that 3 is a factor. So 3 is going to be a factor, and 7, 3 times 7 is 21. 3 is prime, and so is 7. And all my bottom numbers, right, all the kind of extensions of my main number are prime. They're circled, so I know that this is my prime factorization for 42. It's 2, 3, and 7. Okay, and if I multiplied all of those together on a calculator, it'd get 42. All right. Okay, let's look at another couple. So this one, I have, it's not even, so 2 is not a prime, but I do know again that 3 is. So I'm going to do 3. Let's see, 3 goes into 60 20 times, so 63 would be 21. And then 21, just like we did before, is going to be 3 and 7. 3 is prime, 3 is prime, 7 is prime. Okay. Now on to 170. It is even, so I'm going to pull out my 2. Half of 170 is 50 plus 35, 85. 2 is prime, 85 is not. So I'm going to break that up. I'm going to pull out 5, because it's pretty obvious that 5 is a factor. If I pull out 5, that would be 17, I think. Yeah, 17 is my other factor, and 17 is prime, so again, I am finished. Okay. Sometimes you'll have ones that are, kind of this short. It's just 3 prime factorizations. Sometimes you'll get ones that are quite a bit longer. So if we did, let's say 144. All right, if I break that up, I could do 2. In this case, I know it's 12 times 12, so let's do that. 12 and 12. Neither of those are prime. Break it up again. I've got 4 times 3 and 4 times 3. 3's are prime, 4's are not. Alright, break up my 4's. I've got 2 and 2 and 2 and 2. And now all of these are prime, and that's my prime factorization. 2 times 2 times 2 times 2 times 3 times 3 equals 144.